This video is the 7th video in the complex numbers set of videos, and in this video we're going to look at dividing complex numbers. Firstly, we must be able to divide a complex number by a real number. And the most important thing to note is that when you divide a complex number by a real number, you divide both the real and imaginary parts by that number. This should be quite simple, but is best explained by going through an example. In example 7.1, it says divide 6 plus 8i by 2. To do that, we can rewrite this as 6 plus 8i divided by 2. That in turn will lead us to 6 divided by 2 plus 8i divided by 2, which will end up with 3 plus 4i. This doesn't become any more complicated. Sometimes you just might be left with a fraction instead of a whole number when you're dividing by a number, but that's perfectly fine. Towards the end of this video, we'll be going through more examples where you're dividing a complex number by a real number. The second thing we have to be able to do is divide one complex number by another complex number. When dividing by a complex number, there is slightly more involved because you want to remove the imaginary part from the denominator. To do this, multiply both the numerator and denominator by the conjugate of the denominator. And this is best explained by going through an example. And I'm going to do example 7.2 to begin. This here says divide 3 plus 4i by 1 plus 2i. Write your answer in the form a plus bi, where a and b are real numbers. To begin, I'm going to write down what we have. So 3 plus 4i, and we're dividing that by 1 plus 2i. Next, what I'm going to do, as it says, you have to multiply the numerator and denominator by the conjugate of the denominator. Now, the conjugate again is where we take the denominator's 1 plus 2i and we change the sign of the imaginary part. So this becomes 1 minus 2i. And we multiply both the top and the bottom. What I like to do then is split them. So I split the top line and the bottom line, and I'm going to deal with each one individually. So the top line I have here indicated by the red, and this is 3 plus 4i multiplied by 1 minus 2i. This becomes 3 by 1 and 3 by minus 2i, 4i by 1 and 4i by minus 2i. Multiplying it out, we get 3 by 1, which is 3, 3 by negative 2, which is negative 6i, 4i by 1, which is positive 4i, and 4i by negative 2i, that becomes negative 8i squared. Next, I'm going to underline the like terms. So we have minus or negative 6i and plus 4i. And then here we have the I squared, and I squared is the same as negative 1. This means that we'll end up with 3 having minus 6i plus 4i will give us negative 2i. And then we have minus 8 times minus 1. Meaning now that we'll have 3 minus 2i plus 8. 3 and 8 will give us 11 minus 2i. So the top part of this fraction has changed to 11 minus 2i. The bottom part of the fraction, we have 1 plus 2i multiplied by 1 minus 2i. Very similar to the last time, we have 1 multiplied by 1 and 1 multiplied by negative 2, 2i multiplied by 1 and 2i by negative 2i. That will leave us with 1 by 1, which is 1, 1 by negative 2i, which is negative 2i, 2i by 1, which is 2i, and then 2 by negative 2, which is negative 4, and I by I squared. Then we have negative 2i plus 2i, that will cancel, so we'll be left with 1, and then here we have an I squared, so that's equal to minus 1, so that will be changed to minus 4 times minus 1, so this becomes 1 plus 4, which is 5. Something to note here is you'll know if you're doing this question correctly if the i's on the denominator cancel out and you're left with just a real number. That real number could be 5 or 10 or even a fraction, but as long as the imaginary parts cross out or cancel out, you know that you're on the right track with your dividing a complex number by a complex number. To end this question, or to finish it off, I re-put the parts back together. So the top part, or the numerator, has changed to 11 minus 2i, and the denominator has changed to 5. Now, if we note what it's asking in the question, it wants it in the form a plus bi. So we need to write the a by itself and the bi by itself. That means we'll have 11 over 5 minus 2 over 5i. Example 7.3, it says express the expression below in the form a plus bi, where a and b are real numbers. So exactly like the last question, here when we get a fraction, we multiply the top part and the bottom part by the denominator's conjugate. So the denominator here is 2 plus I, so the conjugate is going to be 2 minus I. So we multiply the top part and the bottom part by 2 minus I. I'm going to separate that out again. So the top one I'm going to label in red, and the bottom part I'm going to label in blue. The top part, we have 11 minus 7i times 2 minus I. That means we'll have to multiply the 11 by 2 and the 11 by minus 1. And then we'll multiply the minus 7i by 2 and the minus 7i by minus I. That will leave us with 22 minus 11i minus 14i plus 7i squared. Here the like terms we have are minus 11i minus 14i, and then we also have that the I squared is negative 1, meaning we'll end up with 22 minus 25i plus 7 times minus 1. Then we'll have 22 minus 25i minus 7. 22 minus 7, we'll get 15 minus 25i. So now the denominator is going to change to 15 minus 25i. The bottom part then we have highlighted in blue, and that is 2 plus I times 2 minus I. Multiplying that out, we'll get 2 times 2 and 2 times minus I times 2, I times minus I. That will leave us with 4 minus 2i plus 2i minus I squared. Again here, we know that I squared is negative 1, and I'm going to add the like terms together, which is the minus 2i and plus 2i, which means that they'll cancel out. As the imaginary numbers here have cancelled out, the negative 2 and the plus 2, I know that I'm on the right track with this question. Next, I have 4 minus minus 1, which is 4 plus 1, which is 5. Now I'm going to replace the numerator and denominator with what I know they are. And here we have 15 minus 25i over 5. Now again, it wants it in the form a plus bi, so I'll end up with 15 over 5 minus 25 over 5i. 15 over 5 will break down to 3, and 25 over 5 will end up with minus 5i. Finally, example 7.4, it says rewrite the expression 5 plus 4i over 3 minus 2i in the form a plus bi, where a and b are real numbers. Again, I'm going to rewrite my fraction here, 5 plus 4i over 3 minus 2i. To simplify this, and to write it in the form a plus bi, I multiply the numerator and denominator by the denominator's conjugate, which is 3 plus 2i. Separating it out, I'm going to label the top one, or the numerator, as red, and the bottom one, or the denominator, as green. The top part then, we are left with 5 plus 4i multiplied by 3 plus 2i. Multiplying that out, we have 5 by 3 and 5 by 2. 4i by 3, 4i by 2i. That means we'll get 15 plus 10i plus 12i plus 8i squared. Here I'm going to add the like terms, which is the 10i and 12i, and I'm going to replace the I squared with negative 1, meaning that I'll end up with 15 plus 22i plus 8 times negative 1. That will leave me with 15 plus 22i minus 8. The 15 minus 8 will leave us with 7 plus 22i. The denominator then, we have 3 minus 2i times 3 plus 2i, meaning we'll have to multiply the 3 by the 3 and the 3 by the 2, the 2 by the 3 and the 2 by the 2. So that means we'll end up with 3 times 3, which is 9, 3 times 2i, which is 6i, negative 2i times 3, negative 6i, and negative 2i by positive 2i will get negative 4i squared. Again, here I know that the 6i and the 6i are like terms. We have a plus 6i and a negative 6i, so they'll cancel out and give us 0. I now know that I'm kind of onto the right track here because the i's, or the imaginary parts, in the denominator have cancelled out. And I'm also going to replace the I squared with negative 1, meaning I get 9 minus 4 times minus 1, meaning I'll have 9 plus 4, which is 13. Putting the two of them back together then, I'll end up with 7 plus 22i over 13. As this is wanted in the form a plus bi, I'm going to rewrite that as 7 over 13 plus 22 over 13i. They can't be simplified down, so they're written as rational numbers, and that's perfectly fine because it's looking for real numbers, which includes rational numbers. Now we've come to the end of video 7. The main thing to remember with this one is when you are dividing a complex number by another complex number, you need to remember to multiply the top part and the bottom part by the conjugate of the bottom part or denominator. If you remember that, the question becomes the same every single time, and if the imaginary parts on the denominator cancel out, you've most likely done the question correctly.